In this recording, we will be talking about a very important concept in R, which is subsetting. In subsetting, we use square brackets to access specific elements of a vector. For the vector that we created previously, codes, if you remember, let's create it again, codes, C, let's say Italy equals 10, Canada equals 20, and India equals 30. So what is code? Codes is a vector that contains 3 numbers and it has names, right? You can access, if you'd like to access a part of this vector, we use a square bracket. Again, if you'd like to access partial, some elements, specific elements of a vector, we use square brackets. You can use this in different way. You can use codes, square brackets number 2. That means, please take me to the second observation of that vector, which is Canada 20. Right? You can get more than once. If you'd like to access more than one entry, we use one of the options. We use the vector concatenate C1, 3. What does this mean? Give me the access to the first and third observation. So these are the indices. You can get more than one entry by using multi-entry vector as an index. So there's the index C1, 3. Give me the access of the first and third entry of the vector codes. So it tells me that, oh, this is Italy and India, 10 and 30. Also, we can use the sequences to get access to the code. Like we can say codes, give me access to, this is sequence, right? Not vector. To the first and the second observation of the vector codes, right? Which is Italy and Canada. In this codes vector, because we have names, we can use the names as well. We can access the entries using these names. So codes, give me access to the codes or observation that has a name of India. It's 30. But if you'd like to access to more than one, you can use the C. So codes C, give me access to the column that has a name of Egypt, not Egypt, Italy, and Canada. We don't have Canada, Italy, and Canada. We have a problem with, oh, Canada is not well defined from the beginning. We missed a, okay, that's fine. So it's Canada, it's misspelled at the beginning, so we can change it for you. So now it gives me the values, the entries, using their names. So this is the subsetting, and again, it's a very important concept in R to use subsetting to get access to specific values in the vector. And this can be achieved using brackets. Let's clean this and do something else. Do you remember the murders data set? Let's try to get the structure of the murders. Do you remember that we have state, abbreviation, region, population, total? We can view this data, by the way. And let's try to do subsetting here. Again, we have a data frame. Data frame is murders, so murders. And I would like to have a specific look to one of the columns, let's say region. Not only this, I would like to look at the first 10. Now look, murders, $sign region. That means now we are looking at the vector. This is vector, not data frame. Murders is a data frame, is a table. Murders, $sign region is a vector, it's just column. The column that contains region, all of this. Because this is vector, now we can use square brackets to look at specific observations. We can say, let's look at C from 1 to 5. We have south, west, west, south, west. Let's look at not C from 1 to 10 as a sequence. We have the first 10 observations. What if you would like to look at C from 40, not from 40, 40 and 50, or 49 and 50 of the regions? Or maybe we want to look at states. Let's change region states, the last 2 states, West Virginia, Wisconsin. Let's look at the first 2 states, 1 and 2, Alabama and Alaska. Let's look at murders at the $sign state. Let's look at C, the first, comma, the second, comma, then from the 5th to the 10th to the 9. Look at the sequence inside the function concatenate. We have the first, Alabama, then we have the second, Alaska, then we have number 5 is California, number 6, 7, 8, 9. So this is subsetting. It's very important, as we said. You can access proportion of the vector using square brackets. Let's talk about something else quickly here. So let me clean this, which is the coercion. In general, the coercion is an attempt by R to be flexible with the data types. When an entry does not match what is expected, some of the pre-built R functions try to guess what was meant before throwing an error. This also can lead to confusion. So let's have an example. Suppose that we try to combine numbers and character. Let's say x. Let's define x to be the vector contains 1, comma, USA, comma, 3. So we said in advance, we did not get an error, so look at x. x1, USA3. We have two things here. We did not get an error. R coerced the data into characters. It guessed that because you put a character string in the vector. You meant to say 1, 3 actually are characters. So we put characters, but we did not put quotes, right? And remember that in the past we said vectors must be all of the same type, either numeric or characters, right? But now we mixed up. We put 1, 3 as a numeric and USA as character. We are expecting to get an error, but R coerced this into characters. He said, okay, this is character. He meant to put quotations around the 1 and the 3, but he forgot. So now we have characters. So if you try to check the class of X, it's character. And look at them here, double quotations between the 3 and the 1. So R forced the 1 and the 3 to be character. So the class of the X is defined as character. And the other thing is, R offers functions to change from one type to another. You can turn numbers into characters and vice versa. This is important. These are important functions. If you define X to be a numeric number, vector, between 1 to 5 sequence, what is X? X between 1 to 5. It's a numeric. What is the class of X? It's integers. You can change this to be character if you would like. So you can define Y, a new variable. What is the new variable? It's going to be as character of X. So take X, change them to character. Take X values as a vector. Change it to a character vector, not a numeric vector. So check Y. Y is 1, 2, 3, 4, 5. But what is the difference between X and Y? X was an integer, numeric, 1, 2, 3, 5 without quotations. In Y, it's treated as character. So these are 1, 2, 3, 4, 5 between double quotations each. What if you'd like to return it back to numeric? You can easily say, okay, let's get Y again as numeric of Y. Because it's now under the name of Y, then you can overwrite the Y by itself. So now we have Y becomes a numeric again. Y is a numeric. Sometimes when the function tries to coerce one type to another and encounters an impossible case, it usually gives us a warning and turns the entry into a special value called NA. NA means not available. For instance, let's say X, this is character, this is character, this is character 3. So it's clear that class of X is character, but let's say as a numeric. Let's change X to be numeric. Can we do this? X contains 1, B3. Can you change this to numeric? Warning, NA is introduced by coercion. It gives me 1, NA not available, 3. 1 can be numeric, 3 can be numeric, but B cannot be numeric. So R cannot guess for what number you want when you type a letter, in this case. So it doesn't try. So when you have NAs, NAs usually they're generated or they're used as missing data, missing variables. And we'll be seeing all of these NAs in our real-life datasets in the future.